Good day, Computer Science 2A. In the previous tutorial, we discussed the use of the visitor design pattern in a very basic sense to enable the printing of text onto the console. Today we're going to do a more advanced version of the visitor design pattern that will utilize a JavaFX canvas to draw objects onto the canvas. Just like in the previous tutorial, we are still going to be making use of the two primary interfaces for the visitor design pattern, the abstract visitable interface and the abstract visitor interface. So in order to do this, we're going to have to begin creating some packages in order for this to work. So let's create a model package that is going to then store all of our data members as well as our visitor. We're going to also create a new package for the user interface, which is going to store the canvas that we're going to be drawing some objects on. In order for everything to work, we're going to need a new class, which is going to be the main entry point for our program. Okay, we'll come back to the main later. It is not in this example going to be the client. We're going to use the canvas as the client, and I'll explain why later. So inside our model class is create a new interface. We need to create our first interface of the visitor design pattern, which is going to be the abstract visitable interface. So the iDrawable interface is what I'm going to call this. You will note that in the last example, we used an iPrintable interface. We are not going to name the interfaces abstract visitable or abstract visitor. We're going to give them meaningful names based on what they're going to do. So anything that is drawable is going to be in the going to implement the iDrawable interface. And if something is going to be a visitor that is going to draw, we're going to then name it appropriately as well. So let's have the iDrawable interface, and this is going to be our abstract visitable interface. That's going to define the very important public void accept method. And this method is solely responsible for enabling the visitor to visit our object. So we need to then pass the visitor interface as a parameter, but we don't yet have a visitor interface. So let's create a new interface, and I'm going to call this one iDrawVisitor. And this is going to be, therefore, our abstract visitor interface. And the abstract visitor interface is responsible for defining the visit methods for each object. Now, we don't have any objects, so we won't have any visit methods. But inside of the iDrawable interface, we can now use the accept method here to then make use of the iDrawVisitor interface. So in this case, we now have an abstract visitable interface that is fully functional. It has all the functionality that we could possibly require, because all it needs to define is the visit method that will enable the visitor to come visit the object. Speaking of objects, let's create some objects that now implement the iDrawable interface. So let's create some shapes, because we're going to draw some shapes onto our canvas. So let's create a class. And the class is going to be a rectangle, and this particular class is going to then implement the iDrawable interface. You will now note that there is an error here that says that we don't have the required methods from the iDrawable interface. So if we then implement that, we'll now get the accept method. This method will then enable any visitor to come and visit this particular object. Now, in order for that to happen, we need to now define the functionality that we want to take place inside the visitor interface. So now that we have a rectangle, we want the visitor to be able to draw the rectangle. So inside the iDrawVisitor interface, we're going to want to create a public void draw rectangle R. This means we want to be able to draw our rectangle object that we've just created. Now, in order for that to work with the visitor needs to actually get the data of the rectangle. And this is done by passing the object via that draw method that we just implemented. So visitor.draw, and we want to specify our self via this reference to be the thing that we want drawn. So when the visitor comes to visit the instance of the object is going to pass itself as a parameter to the visitor. And then when the visitor then implements this interface, it will then implement a rectangle draw method. Let's add another class, a new class in the form of a circle, which is also a type of shape. But more importantly, it is going to implement the iDrawable interface. And then we're also required to implement that method to then accept the visitor. Now we want to pass the data to the visitor, but in order for that to happen, the visitor needs to have a visit method that will enable it to do something with the data. In this case, draw the circle. Where it's going to draw it, we haven't defined yet. How it's going to draw it, we haven't defined yet, but we want that any visitor has the ability to draw a rectangle and draw a circle, because we have rectangle objects and circle objects. So if we look at this, we have now defined the visit methods inside our abstract visitor interface, and we have now defined the abstract visitable interface, as well as a rectangle and a circle, which then implement the abstract visitable interface. Therefore, the rectangle is actually concrete visitable A, and the circle is concrete visitable B. So, concrete visitable A, and then in the circle, we can label it as concrete visitable B. And now you will note that the circle has been also given the ability to be drawn by the visitor, but it needs to pass its data. So in order to do that, we're going to go visitor.draw, and we want to draw this object, this circle. Okay. So now that we have the ability to pass the data to the visitor via its interface, we now need to provide some kind of meaningful data to actually send to it. So we're going to be using low-level rendering techniques for JavaFX Canvas, which requires that we have an X coordinate, a Y coordinate, a width, a height, and a color for what we want to draw. And now all of this is going to be part of this rectangle. So we're going to need to have a public int X, a public int Y, a public double width, public double height, and a public color C. Now you will note that the color here doesn't know what it is, therefore we need to import the JavaFX scene paint color. If you use the AWT one, it won't work. You will also note that I've made these public. You are not going to do this. You are going to make these private and use accessors. However, for the sake of brevity, I am going to make them public, or else we're going to have a very long tutorial. So please make use of accessors and private variables with appropriate information hiding. So this will enable us to get the data out of the class. Let's now enable a way to put it into the class. So a constructor, public rectangle, is going to accept an int X, int Y, double width, double height, color, and now we just need to go this.x equals x, and I'm just going to do this. This dot y equals y, this dot width equals width, this dot height equals height, and this dot color equals color. So now we have a fully functional class. The class has the data, It has the ability for us to set the data. It also has the ability, because these are public, to get the data out again. And then it has the ability to pass all of this data via the this reference to the visitor through its interface so that it can then render it however it sees fit. Likewise, with the circle class, the circle is also going to need to have some things in it. It is going to need, let me just copy all of this for the time being. It is also going to need to have an X and a Y starting location, but instead of a width and a height, it's going to need a radius, but then also a color. So let us create a public circle and as the constructor, which will enable us to get the data in, and we can then pass in an int X, an int Y, a double radius, and a color. We can then initialize these to our variables in our class. So this dot X equals X, this dot Y equals Y, this dot R equals R for the radius, and this dot C equals C for the color. So the circle, just like the rectangle, has the ability to store the data that we need, input the data because this is all public, which is really bad. It can also get the data out via passing it to the visitor. Okay, so now if we think about what we need to do next, what we need to do now is we need to actually implement a visitor that will then be able to implement this interface and then draw the rectangle and draw the circle. So let's create that class now. Let's go out of there. I went in with the wrong option. New class, and we're going to call this one a draw shapes visitor. And now the draw shapes visitor is actually the concrete visitor. And the concrete visitor needs to implement the iDraw visitor interface, because the iDraw visitor interface defines which functionality is required. So now we add the unimplemented methods, and now we have a draw method and a draw method. Okay, but now you might be wondering, how does the visitor actually draw on the canvas? Well, first things first, we don't have a canvas. So let's add a canvas, so a new class. So the canvas, I'm going to call custom canvas. Now the custom canvas is going to actually extend canvas. Now, the canvas that it's going to extend is the JavaFX scene canvas. And the canvas is actually going to be our client in this example. The reason it is the client is because it's going to manage the interaction between the visitor and each of the objects. And this is going to be done by using the graphics context of the canvas. So in order for this to all work, we actually need a private graphics context. I'm going to call it GC. Now the graphics context, if you think about it from the sense of the example, is kind of like a paintbrush or a pencil. When the visitor comes to draw on the canvas, it needs to have an implement with which to do that. Now that is in the form of the graphics context. Now the graphics context we actually have to get from the canvas itself. But now if you think about what the client has to do, let's look back at our diagram. The client has to manage the visitor via its interface, as well as all of the visitables, and then get the visitor to go and visit the visitables. So in order for this to happen, the canvas, which is the client, needs to know about the visitor. It also needs to know about all the objects that need to be drawn. It then finally needs to get the visitor to visit the objects. So if you think about this, we have a visitor object, the draw shapes visitor. So we can actually instantiate a draw shapes visitor, and then we can instantiate it using, say, a constructor. So public custom canvas, and then we can instantiate our visitor, draw shapes visitor. So this will then give us the visitor that we need. Now we just need to know which objects it needs to go visit. So if you think about the structure of our program, we're going to be wanting to draw rectangles and circles, but these all implement the iDrawable interface, and we want to manage all of our interactions as far as possible through our interfaces. So what we're going to do inside the canvas is we're actually going to store our objects as an array list of iDrawables, and these are going to be our objects. And they're not going to come from us, because somewhere else in the program, they're going to assign the canvas the things to be drawn. So at this point, we actually need the ability to get these into the program. Okay, so let's provide a function with which to do that. So underneath our constructor, I'm going to create a new method, a public void, and I'm going to call it setObjects. And it's going to take a parameter, and the parameter is going to be an array list of objects. So this method's entire job is to do the following. It is to accept a set of objects, so objects equals O, and assign it to the internal state of the canvas. But once all of the objects have arrived, and we've created the canvas, we now have everything we need to then get the visitor to start going and visiting the objects. So in order to do this, the outcome is we want to redraw the canvas. So redrawing the canvas should enable us to then get the visitor to go visit the object. So let's implement a, well, this could possibly be then a private redraw canvas method, and the redraw canvas method is then going to be responsible for sending the visitor around private void redraw canvas. Okay, so now the ultimate goal of this redraw canvas method is once the objects have been given to the canvas can then be redrawn by the visitor. But now we have the visitor, but the visitor needs the tools to actually do the drawing. And I told you the graphics context is the tool that we're going to be using. Okay, so in order to do this, we need to actually get the graphics context. GC equals get graphics context 2D. That'll get us the graphics context. Now the next thing we need to do is we need to give the graphics context to the visitor. Let's go look at our visitor. Okay, so our visitor needs the tools to draw. So in the visitor class, we can create a private graphics context reference. I'm going to call it GC. And now we need to get this from the canvas. So let's do that via a method. I've imported the context. There we go. So let's have a public void set graphics context, which will accept a parameter of a graphics context object. This tells the visitor which canvas to draw on. Okay, so in doing that, we now just need to go this.gc equals GC. Okay, now that we have the graphics context, we can actually use the object's information to then draw them using the graphics context. So we're going to now draw a rectangle. In order to do that, we need to go gc.setFill, which will set the color of the graphics context so they can draw the right color. So we're just going to get this from r.c, the color of the rectangle. this should be an accessor method if you have done it with private attributes. The next thing we can do is go gc.fillRect, which is responsible for filling a rectangle. Now this requires that we have the rectangle starting X location, starting Y location, its width, and its height, all of which I'm getting from the rectangle, because the rectangle is going to pass its own data to the visitor to draw. This is the equivalent of the visitor interpreting the data now that's happening. With respect to the circle, we are now going to just draw a circle. In order to do that, we're going to set the graphics contexts full again, but now we're going to use the circle's color, and then we're going to go gc.filloval. Okay, and we're going to be using the circle's X starting location, the circle's Y starting location, and the width and height. Now, the width and height in this case are effectively just twice the radius of the circle. So we can go circle.radius times 2, which gives us the diameter of the circle. And circle.radius times 2 will give us then the height of the circle, which will also be the diameter. So if it's a circle, it should have the same width and height because it has a radius. Okay. So now we actually have the ability to draw the objects using this visitor object. So inside of our canvas, now all we need to do is get the visitor to do that job. So we're going to now go visitor dot set graphics context and pass the graphics context in. That would then give the visitor the right canvas to start the drawing on. Now that we've done that, we just need to send the visitor to each object. So we can go for iDrawable using the interface O in objects. We can now make it that object accepts the visitor when it comes to visit. And that should then enable us to have completed the visitor design pattern portion of this. You will note there's something very important happening here. The visitor design pattern happens almost entirely at this stage, where we send the visitor to each object. I'll explain it more once we've finished with the main of the program. Okay, so in the main of the program, the main of our program is actually going to be a JavaFX application. So extends the JavaFX application. Let us import it and then implement the required start methods. In order for that to happen, we need to, in the main of our program, launch using the command line arguments. And that will then give us our primary stage. So now all we really need to do is add the canvas to the application and display it. But let's do this in a little bit of a roundabout way, and let's add a button so we can more easily track the stages of the process of the visitor design pattern. So number one, let's create the canvas, because that's what we really need to do here. So we can create our custom canvas equals new custom canvas, and I got it from our UI package. And now with the canvas, what I want to do is I want two things to happen here. I want the canvas to be resizable with the window that it's in, so that we always have the canvas occupying the maximum possible space. But I also want to have a button to show the functionality off. So let's create a button. And let's give it, needs to be a capital B. And let us make it have the label of draw shapes. We'll need to import the button. And now we need to give it the action event that's going to tell it what it needs to do. So let's go button.set on action. And I'm going to set the action that's going to take place in the form of a lambda with an action event E, and I'm going to define the lambda and the code to execute when it is passed. There we go, import the action event. So now what I want to do is when I click the button that's going to say draw shapes, I want it to create the shapes and send them to the canvas. The canvas, being the client of the program, is then going to be responsible for sending the visitor to each of those shapes. So let's create an array list of type iDrawable, and I'm going to call this objects equals new array list from Java util. We can then import the iDrawable, which I have misspelled, from our model. So import model.iDrawable. Now that we've got an array list to store all the objects via their interface, let's instantiate some objects. So let's go and create an iDrawable and call it R for rectangle equals new rectangle. So you can see I'm casting the object to its interface, which will enable me to pass any object around via the interface, which is precisely what we want when we're working with a visitor design pattern. So let's import it from our model, and then we have to pass it, well, pass in the parameters for the constructor, so the X location, the Y location, the width, and the height, followed by color, and I'm going to make this a dark green rectangle. Likewise, I can instantiate an iDrawable C, which is going to be a new circle. And into the circle, I can pass the starting X coordinate, the starting Y coordinate, the radius of the circle, and a color. I'm just going to make this one red. Okay, doesn't know what our circle is, so let's just quickly import it. So what we're doing here effectively is we're creating a rectangle and a circle, but we're then going to store them via a reference to their interface. So what that enables us to do is add them now to our objects array list. So objects.add rectangle and objects.add circle. They're now both stored in our array list. All we need to do now is pass all of the objects to the canvas. Canvas.set objects, and we can then pass in the objects. Now what this is going to do when the button is clicked is create the rectangle and the circle, add them to our array list, and then send them to the canvas. Okay, more on that in a little bit. But now we need to add this canvas as well as the button to our JavaFX application. So in order to do this, we need to create a scene graph and add that to the stage. So in order for this to happen, let's create a root node. So I'm going to create a border pane as the root node. Equals new border pane. Okay. That is going to be our root node of our scene graph because I'm using the border pane, so I want to put the button at the top and the canvas at the center. But in order to store the canvas and make it resizable, I want to have a stack pane. I'm going to call this one container, and that is going to be a new stack pane. And I want to make it that I add the canvas to this container, and then when I resize the window, it should resize the stack pane, which will then in turn resize the canvas. So we always have a canvas that's the maximum possible size. Okay, so in order to do this, we're going to make it that the canvas is width property is then bound to the container width property. Okay, likewise, we can then bind the height property to that of the container as well. Furthermore, we can actually set how small we want the starting size of the container to be by setting the preferred width and height. So we can go container.set preferred width, and we can make the preferred width something like 200, doesn't need to be very big. And we can go container.set preferred height and make that, say, 150. We don't really need much space for this. And then what we can do is we can add the canvas to the container. So we can go container.get children.add, and we can then add the canvas to the container. Now we just need to add the button and the container to the root node to create our scene graph. So we can go root.set top. Maybe we'll put the button at the top. And we can then add the center to be the container. Okay, now that we've set up the scene graph, we can now create the scene by going scene equals new scene, and we can place in that the root node of the scene graph. We just need to then import the scene. And then lastly, we can then load the scene onto the stage and show it to the user. This is done by using the primary stage provided by the JavaFX application. And we can set scene, and we can put in the scene. And lastly, we can go primary stage dot show. Okay, so let's see what this does if we now run this program. So if we run it, we're going to get a little window, and the window has a draw shapes button. And when we click the draw shapes button, it should show us a red circle and a green rectangle. So what has happened here is when we click the button, let's actually go through it in code here. When we click the action on the button, it is going to then create the objects that we want to have visited. Those objects are then sent to the client. So in this case, they are sent to the canvas's set objects methods. So if you go to that set objects method, it receives the objects, and now that it has the objects along with the visitor, it has everything it needs to now tell the visitor to go visit the objects. So in this case, it's going to call the recanvas method. Well, redraw canvas method, sorry, which will then get the graphics context and then give it to the visitor. So that enables the visitor to now begin drawing on this canvas. Now that the visitor has the tools that it needs, the visitor just needs to then go and visit every object by using the accept method of the object. So if we were to go visit a rectangle, the rectangle will accept the visitor via the interface and then pass its data to the visitor so that the visitor can draw it. So it'll pass its own data to the visitor's draw method. So then the visitor is going to then be able to draw the object with the data passed to it using the graphics context. Thus, the visitor visits the object, the concrete visitable, and then visits it using its draw method to then render it onto the canvas. Okay, this may seem very convoluted, but it isn't really. Because if you base it on the principle of the visitor design pattern, we have these two interfaces, the abstract visitor interface and the abstract visitable interface, which are then going to be managed by the client, in this case it was the canvas, to then tell the visitor, the concrete visitor, to go and visit each object, which is then done via the interfaces of each of the accept methods and the draw methods. The concrete visitable then has the ability to pass its data back through the interface to the concrete visitor. So there's this back and forth that takes place. Okay, ladies and gentlemen, this then concludes the tutorial on a more advanced form of visitor, this is the kind of visitor you're going to be expected to do in your practical test and in your game. You're going to have to be able to accrue the state of your objects in your whatever project that you're doing and render them using a visitor. So if anything, practice this particular kind of visitor. Thank you.